We often associate dogmatism with religion. It is seen as a rigid adherence to doctrine. But can science, a realm supposedly governed by reason and evidence, also fall prey to dogmatism? The history of science, unfortunately, reveals a recurring pattern. New ideas, especially those challenging established paradigms, often face strong resistance, not always from a place of logic, but from a place of entrenched belief. This resistance, this clinging to outdated notions, is dogmatism, plain and simple. It has hindered scientific progress time and again. The pursuit of knowledge, regardless of the discipline, demands open-mindedness. It demands a willingness to consider new ideas, even those that challenge our most cherished assumptions. Science, as a beacon of human reason, must be particularly vigilant against the allure of dogmatism. For when science becomes dogmatic, it ceases to be science. Ludwig Boltzmann, an Austrian physicist, dared to delve into the world of atoms. He proposed that the behavior of gases could be explained by the statistical mechanics of these tiny particles. This was the late 19th century. The very existence of atoms was still hotly debated. Boltzmann's ideas, though elegant and powerful, were met with fierce opposition. Established physicists, giants in their time, clung to classical thermodynamics. They saw no need for Boltzmann's atoms. His work, they claimed, was too speculative, too radical. The weight of their authority, their unwillingness to even consider a new perspective, created a climate of hostility that Boltzmann found unbearable. He tragically took his own life in 1906, his brilliant work still largely unappreciated. Gregor Mendel, a contemporary of Boltzmann, faced a similar fate. This Augustinian friar, through meticulous experiments with pea plants, uncovered the fundamental principles of inheritance. His work, published in 1866, laid the foundation for the entire field of genetics. Yet it was met with indifference. The scientific community, engrossed in Darwinian evolution and cell theory, simply ignored Mendel's findings. His work was too abstract, too mathematical for the biologists of his day. They lacked the framework to grasp its significance. It was not until the early 20th century, long after Mendel's death, that his work was rediscovered. Only then did the scientific world realize the profound implications of his pea plant experiments. Section 4. Planck's Quantum Leap. A challenge to the pillars of classical physics. Max Planck, a German physicist, ushered in the 20th century with a revolutionary idea. He proposed that energy, instead of being continuous, was emitted and absorbed in discrete packets, which he called quanta. This radical notion, the cornerstone of quantum mechanics, shook the very foundations of classical physics. Planck himself initially struggled with the implications of his own discovery. The scientific community, steeped in the deterministic world of Newtonian mechanics, met his theory with skepticism. It seemed absurd that energy, which had always been considered continuous, could be quantized. But Planck's theory, though strange and counterintuitive, explained experimental results that classical physics simply could not. Section 5. The Unending Quest. Embracing Uncertainty and the Evolution of Knowledge. Even Albert Einstein, a champion of scientific revolutions, displayed resistance to certain aspects of quantum mechanics. His famous quote, "God does not play dice," reflects his discomfort with the inherent uncertainty at the heart of quantum theory. This discomfort, however, did not lead him to reject the theory outright. Instead, it fueled his desire to understand it more deeply. Science is not about certainty. It is about the pursuit of knowledge, a journey that often leads us down unexpected paths. Dogmatism, the clinging to outdated beliefs, is the antithesis of this journey. To truly advance, we must cultivate a spirit of open-mindedness, a willingness to embrace uncertainty. We must learn from the mistakes of the past, from the Boltzmanns and the Mendels, and ensure that the pursuit of knowledge remains a vibrant, ever-evolving endeavor.